and going to start sharing screen. Let me see, where is my note? It should be this one. Yeah. Okay. Last class, let's see where we already did we started about CBOM? I don't remember. So we already discussed we already discussed the matplot libraries, pyplot, okay? And we also discussed with pandas, you can also do plotting. So today we will learn the third one, use CBOM, okay? And CBOM can make so it adds a lot of externalities for plotting. And before we move to CBOM, there is one minor thing that also may be interest, okay? So here we will learn cross tab. And it's a cross tab, it builds a table, okay? And that table shows some frequency with which a certain group of data appear. So it's, so over here, the example is we have a tips CSV file and we get it to some data frame, okay? And on the data frame, and if you pick like a certain column here, etc., and if you apply to cross tab, okay, so the cross tab, and then it will generate some table, okay? And it's going to show some frequency. So here is part of the result, what it look like. So it's based on the size. So here size means customer size. Okay, so it's for some restaurants data, okay, about the tips. And for the index, it's the day. Is it like Friday, Saturday, Sunday, and Thursday? Okay, so it's, and then over here, it's just to show the tips. And this is not like just from the data. So it's also kind of does some calculation for the frequency. Okay, so that's what this cross tab can be used for. And then later on, what we see is here it says because not many 1 or 6 person parties, is it? So we get rid of the 1 or 6 person party and just get 5 to or 2 to 5. And we also try to do percentage calculation based on the frequency. Okay, so what you can do is you can use the counts to do some division. Do the division, you need to do the summation and specify along which axis to do the summation, okay? And here, this is for the division and the summation. And then you can find the percentage. And after we find percentage, then we can do using, so here is a pandas plot, do the bar plotting, okay? And then let's take a quick look at, so what is, so this shows the bar plotting. And I remember last class, we also said, is it so in this case, the index, so this is the index as the x-axis for the drawing, is it? And y is the percentage. And for each bar, so it's the column, okay, so the size. So this is from pandas plotting. And before we move on, let's first show you about that CSV file, okay. So here is the CSV file. the tips CSV file. So it has, because later on we will use this more. So it has a total bill is one column, and then it has tip. So tip is column, and the smoker or non-smoker, okay, and the day goes to the restaurant, and the time. So it's dinner or lunch or breakfast, and the party size, is it? And the previous one that we just saw is regarding the size and the day, is it, regarding these two columns. And we can clearly see that cross tab is not regarding this original data. It does some frequency as a calculation for us. And so that you can go ahead to use it. So it's quite helpful, convenient way. And then next, let's move on. So that's regarding cross tab from pandas. So what the next one try to show is we can use CBOM, okay, package for adds-on plotting, okay. And the CBOM is used a lot. It can make things plotting much simpler and also much prettier, okay. And normally, if your data requires its aggregation or summarization, okay, then you can consider using CBOM, okay. So let's see. If you want to use CBOM, you need to import the package. And here we import it as SNS, okay. So still regarding that tips, okay, we are going to do some calculations. So we calculate tip percentage. So we are going to add this new column. Okay, so if you take a look, this is the original, this part is the original data frame, is it? And we add a new column regarding tip percentage. And the tip percentage calculation is based on total bill. Offset the tips, okay, we find the tip percentage. And then we can do the CBOM draw. Okay, and CBOM plotting here, we are going to do the bar plotting. Okay, the bar plotting, then the x-axis is what? Is this tip percentage. And the y is based on the day. So Sunday or Saturday, Friday, something like that, is it? And data is from the tips, so from this data frame, okay? And you can also specify the bar is going to be vertical or horizontal, is it? So here we want it to be shown as a horizontal bar, okay? And then let's take a look at what it looks like. So if you take a look, you will see this is CBOM's bar drawing. Okay, and and also, let's also take a look. So the percentage, is it? And if you take a look at the percentage here, it totally has 244 rows as a percentage. But what over here in our bar plotting is not regarding every single data, is it? So like over here, it also shows for CBOM. So you already, hold on, let me get the student. So here, when it does the plotting, it also, hold on, I need to get a student in. It also does aggregation and summarization. Okay, so it's not purely on the original data for this bar drawing, is it? Then you may ask what of this percentage regarding, is it? And over here, all this percentage is regarding average for the specific day. And here we only pick this 4 days. Okay, it's regarding the average. So it already does the aggregation. So not purely on the original data. Okay, so be careful here. And with SafeBound, you will also see there is a there is a line out of the bar. Is it? So what that is? Okay. So this represents the 95% confidence interval. Okay, so that's what the SafeBound bar drawing give you some extra information. Okay, so that's regarding how do you use SafeBound. So you specify X and Y and the data source and some other features. Okay, and here let's also show. So I will comment out this one. And let's see, we get to the other one. Okay, so here I add another one called the hue. Okay, and the hue is for time, the time column. Okay, initially we just have the percentage and the day. Is it? Now we also want to consider the time. So time means you have dinner, lunch, and breakfast difference. Is it? So what will it look like? Let me run everything and then run to this point. Okay. To finish it, it will take a little bit. Okay. Haven't got to this point. Okay, we get that, and then let's run this one. And if you take a look this time, the bar drawing, is it? So that hue considers the time. So it also shows the dinner and the lunch with two different bar and for each day. And still, this is average. Okay, not each individual data points. Okay, so already aggregated. Okay, so this is regarding SafeBound's first example we just saw. Okay, it's regarding bar drawing. And what next one try to show here? Okay, so this is the tip is a data frame, is it? So pandas data frame, and we get one column out. So anyway, so that's a series, and then you can call plot, is it? And here we want to histogram. Okay, so it's just based on tip percentage, is it? So the horizontal, the x-axis is percentage, and the y is frequency, and we have the bin size set up. So anyway, so this gave us some distribution idea, is it? And with data distribution, you can also call density. Hold on, let me get. Okay, and you can also use density for the distribution so that you have some idea is about how the density distributed, is it for certain percentage of tips, is that we can clearly see it's kind of between 0 to probably 0.3%, something like that, is it? Okay, so that's regarding distribution. And for SafeBound, here it says, SafeBound makes histogram and the density plot even easier. Okay, with it's called distribute. So distribute plot method. And then it will plot both the histogram and the continuous density estimate simultaneously. Okay, so it has a better feature. So let's see. Hold on, let me get the student in. Okay, so over here, we generate a sequence of number and a second sequence of number. Okay, so the first, it's both a normal distribution. The first based on mean 0 and the second based on mean of 10, etc. And the standard deviation also different. And the size the same, okay, for both data set. And then we concatenate, as if we combine both data set together and generate a single data set, okay. And then what next one then show here is you just call C-bounds distribute plot, and then you select the data set. And you also provide the bin size and the color. We already know this, okay. So it's the same standard as what we discussed before. But over here you can see, so this time it's not two individual plot, is it for histogram and density distribution, is it? So this time you combine both together, is it? So it looks much rich, is it, for your plotting, is it? So that's why we see CBOM has a lot of benefits to also make your plotting richer, okay. Okay, so this we shows features, more features for CBOM. And what next one try to show? Here we have a new data set. Okay, so first let's take a look at that data set. Here we have this data set, and I'm going to share the data set. And it's also a quite large data set. Okay, so it's some macro economy data set. It has a year, quarter, GDP, and a lot of CPI, unemployment, popular inflation. So a lot of data. Okay. So anyway, so it's a quite big data set. And then let's take a look how we deal with that. Okay. So for this data set, we will only pick 4 columns: CPI, M1, T-by rate, and the unemployment. Okay, and here gave us the first 5 rows, a glimpse of the data. Okay, and then what next try to show is we try to do some log difference calculation. Okay, so that's why over here we get this data set. And for this data set, what we are going to do is we are going to do some regression, linear regression. Okay, and with CBOM, with CBOM's regression plot method, it will shows us a scatter plot, and it also fits the linear regression line. Okay, so you will see it's quite rich. Okay, compare if you just do the line plotting. Okay, so over here that's CBOM's regression plot method, and you specify the 2 parameters. Is it you want to do regression? Is it from the data set? Okay, and over here you can also see. And over here we combine both CBOM and the previously learned the pie plot together. Is it? So with pie plot you can add a title. Okay. So then let's see the result. So if you take a look, the result looks pretty rich. Is it over here? So this is a regression line, linear regression line. Is it? And it also gives you all the scattered points, is it, data points regarding the 2 column, the 2 parameters that you see. And this part is from the pie plot. You add the title. Okay. So you can kind of see, is it, the CBOM adds a lot of richer features to your plotting. Okay. And what next one try to show is CBOM also has another very nice method called pair plot. Okay, so the pair plot is it supports histogram or density estimates of each variable for a number of parameters you will consider about. Okay, so here let's take a look. What we will work on is still that macroeconomy data. Okay, so here it's regarding the log. So we try to calculate the log difference data. Okay, so if you recall, it involves, we can go back to take a look. So basically it's regarding this data frame. Is it? So it has 4 columns, CPI, is it unemployment by rate, okay, and M1. So it has 4 columns, is it? So what over here we want to do the pair plot. So the pair plot is to try to find, see some pattern between every pair, okay? So between like CPI and M1, CPI versus T-bill rate and the CPI versus unemployment, and MI versus T-bill rate and M1 versus unemployment. So each pair of the variables relationship, okay, or the pattern between them. So the relationship pattern between them, is it? And also itself's distribution, okay, and the individual variables distribution, okay, distribution. So otherwise, if you use some other plotting, it will kind of complicated, okay. But with C-bonds pair plot, you will see, you just call this pair plot method, is it? And then you specify the data source. And you specify the diagonal kind, what you want to use. And here we wanted to have the kernel density distribution, okay? You can also pick a histogram, is it all auto? So depends on the, so this is regarding the different keyword argument, is it? And also for plotting, is it? You can also specify like the transparency, as if for the color, okay? And here it shows, because it's going to be a group of plotting, is it? So it has a diagonal and off diagonal. For diagonal, what it shows univariate, is it? So the variable itself is distribution. So it's marginal distribution. And the off diagonal, it will give you the joint distribution, so bivariate, okay, distribution. So you will see it's quite simple, is it? So you just have that one method. Did you see it general? Because here we have 4 columns, is it? So that's why the plotting we will have is 4 by 4, is it? And 4 by 4, we have the diagonal. And over here, it's all diagonal. Is it? So diagonal is univariate. Okay, and all of the other is bivariate. Is it? It's one versus is the other. Is it? And you can also clearly kind of see the distribution pattern. Okay, so diagonal, and so all of this means diagonal, and all of the others are off diagonal. Plot. So this is we call pair plot. Is it? It's quite, so just with that single call, you will have all of the graphs generated for us, is it? And it helps you identify the distribution pattern, okay? And so over here it shows, and I wanted to show you the other one, okay? So if we just if you just plug in with the data source, okay, didn't specify the keyword argument, what we will have, okay. So let's just run and see the result. It will take a little bit. My machine is kind of slow. Okay, and then let's see, this time we change, okay. Did you see if you don't specify as the kernel distributed, as a kernel density distribution, then what it gave us is, looks like a histogram, is it? So over here, it gives you histogram distribution, is it, for the diagonal, and for the off-die, it's scattered, okay? So you can pick based on your needs, okay? So that's regarding the pair plot. And what next one, also very interesting, okay, we will see. And a lot of time you also wanted to have multiple plots, is it, for some grouping purposes, is it? So CBON also can help us do that. And with what we call it facet grades and categorical data, okay? So the method, the function is called factor plot, okay, factor plot. And over here, you will have multiple plots, okay, multiple plot. So over here, what we are interested is, we are interested in the tip distribution, the tip distribution. And we will also have, we want to also compare the smoking or non-smoking. So what's the difference between them? Is it regarding the tip percentage based on the day, is it? And we also want to see the dinner or breakfast or lunch, what's the difference, is it? And you can also specify the plotting type. So here we're just going to pick the bar plotting. Okay, and the data source, then you specify the tip percentage less than 1, okay? So that's all of the information that you want to consider for the plotting to give you, especially when you do the data reporting, so it's used a lot. Then with this factor plot, is it, and you specify, then based on your original data set, is it, it will automatically, you can see, generated. So over here, we have 2 graphs, is it? So the left one is non-smoking, and the right one is smoking, is it? So the difference, and also you can see the hue because it's specified by the time. So it also shows you the dinner versus the lunch, is it? And it's bar plotting, is it? And here is the tip percentage, and here's based on the day. But also be careful, okay, all of this is also aggregated data. So basically over here, as previous, it's the average, is it, of the percentage for the day, but based on the category, is it? Because here we have the category difference, smoking or non-smoking, and we also consider the difference between dinner and lunch, is it? And then clearly this generates a very nice report, is it? This kind of stuff is especially useful when you do business business analysis, is it? And when you report to your manager, is it, or like CIO, CFO, something that they want to have this kind of summarization data reporting, is it? Then we can see using this approach, you can generate, so it's called factor plotting. You can clearly generate the plotting regarding different category of the summarization data. Okay, so here we shows, and the next one shows more, okay? So if you want to have more detailed, you can also expand the facet grade. And over there, we just have column, that you can also add row for the multiple plotting, and so for factor plotting, this time it's still based on the tip percentage versus the day, But this time for the row, we will be based on the time, so dinner or lunch. And for column, it's based on smoker, okay? And we still use bar, okay, regarding percentage. Then let's see what it looks like. So now you see, when you add a row, so here you also specify row, when you add a row, you can see the row for the top row, it's regarding dinner, or regarding dinner, but it's what? It's non-smoking versus smoking difference. Then you can see, So clearly from the first row, you can kind of get the tip percentage distribution between non-smoking versus smoking based on dinner time, And then the bottom row, what it shows is the comparison between non-smoking and smoking for different day, And it's for lunch. Okay, so you can get more detailed categorical plotting. Okay, so that's regarding the factor plotting. Okay, and for factor plotting, you can also do, and the previous one, what we show is bar, okay? And what the next one try to show is box, okay? Box plotting, okay? So the box plotting, you will see it's different, okay? So here, we just show the tip percentage, and this time the y-axis is going to be the day, okay? But we are going to not using bar, using box, okay? Still do factor plotting, okay? So let's take a look what it looks like. So you can see it's different. This is called box plotting, okay? Box plotting. So the x-axis is about tip percentage, and the y-axis is regarding the different day, Sunday or Saturday or Thursday or Friday, So this is, so each one shows a box, So what does this mean, And within each box, it also has a vertical line. Probably let me pick a different, So it has a vertical line within each box. So what does all of this mean? So here there are a couple of points, okay, lines that we need to be careful, okay. So this inside the box, the vertical line, and the two vertical line around the box, bounding the box. Okay, these two vertical line and the vertical line outside of the box. And some scattered points. Okay, so all of those. So what do all of those mean? So here it explained. Okay, so box plots, it shows what? It shows you the media. Okay, the media distribution. So that vertical line, middle line shows 50%. So this gives you the media. okay? And the two outer vertical line, so it's represent 25%, so quantile, and 75 quantile. Okay, so a lot of time, if you recall, for data frame, that for pandas data frame, if you do the report, it also give you the 25 quantile and 75% quantile information, as a statistic information. So so those two quantile makes the side box, okay? And this two vertical line, it gives you the minimum and the maximum, okay? So leftmost vertical. So if there is no outliers, that's it. And this diamond dots, then it gives off the outliers, okay? So this gives us all of the box plot, okay? For box plot, you still use a factor plot, but you can specify the kind as a box, okay? So over here, okay, still the information give us is the average, is it in this case, and it's aggregated data. Gated data, okay, so it's not on the original data. So that's what CBOM, okay, normally shows us the information. Okay, so basically for all of the plotting, we completed